Question 4, Part A. In the diagram, the point Q is due east of P. The point R is 38 kilometers from P and 20 kilometers from Q. The bearing of R from Q is 325 degrees. Part 1. What is the size of angle PQR? It's given that point R is on a bearing of 325 degrees from point Q. In order to show that on the diagram, we draw a north-south axis at point Q, and 325 degrees is measured clockwise from north. Now we know that point P is due east of point Q, which means the bearing of P from Q is 270 degrees. So the angle PQR is the difference between the bearing of R from Q and the bearing of P from Q. In other words, angle PQR is equal to 325 degrees minus 270 degrees, which equals 55 degrees. And I've indicated that on the diagram here. Part 2. What is the bearing of R from P? The question is asking for the bearing of R from P. Now P is mentioned right after the word from, so P is our reference point. So I'm going to draw another north-south axis through point P. I'm going to let theta represent the bearing of R from P, and that's measured clockwise from north. But in order to find angle theta, which represents our bearing, I need to find the value of this angle here, angle RPQ. Now we have a known side angle pair, that is 38 kilometers opposite the 55 degree angle that we found in part 1. And because we have a known side angle pair, we can use the sine rule to find angle RPQ. I know the angle between the north-south axis and PQ is 90 degrees because P is due east of Q. And because these two angles are adjacent and adding up to 90 degrees, so they're complementary, 90 minus angle RPQ will give me the value of theta, which represents the bearing that we're after. So let bearing R from P be theta. We're going to use the sine rule to find angle RPQ. So sine angle RPQ over 20 is equal to sine 55 degrees over 38. I'm going to make sine angle RPQ the subject by moving the 20 here over to the other side. So it's being divided here. When we move it over to the right hand side, it's multiplied. So sine angle RPQ is equal to 20 times sine 55 degrees divided by 38. Sometimes it's easier to write it in this form rather than in fraction form. Now to make angle RPQ the subject, we take the inverse sine, using shift sign on the calculator. We take the inverse sine of the right hand side. So angle RPQ is equal to inverse sine of 20 times sine 55 degrees divided by 38 in brackets. And that gives us 25.539 and so on degrees. Now theta is equal to 90 degrees minus 25.539 degrees, which gives us 64.46 degrees. And there's more decimal places there, but I'm going to answer correct to the nearest degree. So we interpret this result as 0.64 degrees as a true bearing. So the bearing of R from P is 0.64 degrees, correct to the nearest degree.